Let's practice some exponential models. The number of Facebook users has doubled every 6 months since starting in March of 2004, at which time there were 500,000 users. What is the growth factor? Well, it says it doubled, so that means my growth factor is 2, because doubling simply means multiplied by 2. What unit is time measured in? Well, it talks about every 6 months, so we are talking about 6-month chunks. So for example, if we're talking about 1 year, that means X would be 2, because there are 2 6-month chunks in a year. So what's the exponential equation? Well, I started with 500,000 users. My growth factor is 2, and then my exponent. Now you'll notice I just put 0.5 for 500,000, so my final answer will have the word million after it. So estimate the number of Facebook users in March of 2007. Now remember, March of 04 is when we started. So if we're looking at March of 07, that's 3 years. So how many 6-month chunks are in 3 years? Well, there's 2 per year, so that would give me 6 total. So I have y equals 0.5 times 2 raised to the 6th power. So I would end up with 32 million followers. Users, sorry. An exterminator sprays 400 milliliters of pesticide that degrades 18% each week. The product recommends a reapplication when less than 10% of the pesticide remains. Write an exponential equation to represent the amount of pesticide at any given time. Now we're degrading, so that's decay. So we start with 400, it decays. Remember, decay is 1 minus the percent decrease. So that gives me the 0.82 for inside my parentheses. So there's my exponential equation. So how much would remain after 4 weeks? Well, if I've got 400 times 0.82, we're going to raise that to the 4th power. Remember, exponent, raise it to the exponent. So that means we're at 180.85 milliliters. The exterminator should come back when there's 50 milliliters left. So when should that happen? Well, after 4 weeks, we're at 180.85. So we've got to kind of go up from there. So, I don't know, I started at, well, let's guess 8. So if I do that, I've got y equals 400 times 0.82 raised to the 8th power. And that got me an answer of roughly 81. That's too much. So I went to 10, 400 times 0.82 to the 10th power. And that gave me 54. Well, that's still too much. So if I go 11, now I'm at 45. So it's got to be at 11 weeks. Because at 10 weeks, we're still above 50. So it's got to be less than 50. All right, so now we're looking at this table. So consider the amount of money in the account shown. Estimate the growth factor. Now, when we're given a table like this, we can remember that the growth factor can be found by taking new divided by old. So I just take 2 consecutive values, doesn't matter which ones. So I'm going to take 287.50 and I'm going to divide by 250. When I do that, I get 1.15, and that is my growth factor. I know it's a growth factor because they're getting bigger. So construct a model. Well, with 2010 as my first year, I'm using 250 as my starting amount. My growth factor is 1.15, and my time period there is X. So what about the value of 2018? Well, if 2010 is my starting point, that means X is 0. That means in 2018, X will be 8, because it's 8 years later. So I use my formula, 250, 1.15 raised to the 8th power, and I would get a value of $764, whoop, wrong button, and 76 cents. And use guess and check. When are we going to have over $1,000 in it? Okay, well, after 8 weeks, we had $764.76. So what would we guess? Maybe 10 or 12? Let's start 12. If I plug in 12, y equals 250 times 1.15 to the 12th, I get 1337.56. Whoa, that's too big. Let's cut the difference and try 10. If we try 10, 250, 1.15 to the 10th, I get 1011.39. Well, that looks pretty close, but just to double check, let's just go down by 1. If I use 9, I end up with 879.47. So it is, the green guy wins 10 years. So it'll take 10 years to have over $1,000 in that account. Most cars decrease in value as soon as you drive off the lot. However, some cars are classics, and classics increase over time. So we've got a Mazda Miata which sells for $23,000 and is depreciating, or a 1970 Ford Mustang, ooh, I love a Ford Mustang, worth $12,000, but it's increasing at 6% each year. Okay, so the Miata has a starting value of $23,000, but it's going down. So if I subtract my 10%, I end up with 0.9 to the x power. There's my Miata. Then I go to the Mustang. And the Mustang starts at $12,000, but it's increasing. So we're going to add the 6%. So we end up at 12,000 times 1.06 to the x. All right. Now use the equation to estimate the value for each car over the next 6 years. So year 1, 2, 3, 4, 5, 6. So you've got, well, you make this the Miata on this side and make this the Mustang on this side. So use the formulas from the previous page to fill in 1 through 6 each year how much is left. Hit pause, figure it out, and then come back and look at your values. All right, assuming I can read my handwriting, that's what the values look like. The Miatas go down 10% a year. Mustangs go up 6% a year. And at what point will the Mustang exceed the value of the Miata? Well, if we're looking at this, go down, this one's higher, this one is higher, this one is higher, this one is not. Year 4, it'll take just 4 years for the Mustang's value to exceed that of the Miata, even though it's 34 years older than that car.